lesson today is about the last part of the physical properties of the electric current. What about the last part? The last part is about the electric resistance. What's meant by the electric resistance? It is the opposition that the electric current faces during its passing through a conductor. What's meant by this? This means that the electric resistance, it is the opposite to the electric current. When the electric current wants to move through a conductor, the electric resistance wants to stop it. Do you understand? So the electric resistance wants to stop the electric current to move through a conductor. What about the measuring unit of the electric resistance and the device to measure it? Number one, the device which is used to measure the resistance is called ohmmeter, but the measuring unit is called ohm. And remember that electric current intensity is measured by a meter and measuring unit ampere. Potential difference is measured by voltmeter and measuring unit volt. And the electric resistance measured by ohmmeter and the measuring unit is ohm. What about the types of electric resistance? We have two types. Number one, constant or fixed resistance. Number two, variable resistance or rheostat. Constant resistance, its symbol is this, and rheostat, its symbol is this. Its shape is the same shape of constant resistance, but slider here, so it is variable. Now, what about the variable resistance? At the first, we must know an important idea. When the length of conductor increase, the resistance increase and electric current intensity decrease. Again, when the length of wire increase, the resistance increase and electric current intensity decrease. What's meant by this? If you move for long distance, you lose your energy, and electric current intensity, if moves for long wire, its intensity will be weaker, will be lower. So there is directly proportional between resistance and the length of wire, but there is inverse relation between resistance and electric current intensity. What about the structure of variable resistance? Variable resistance, number one, porcelain cylinder and metallic wire coiled around it, and we have slider to move it on copper bar. Okay, if we increase the length of metallic wire and slider move to here, this means we increase the resistance and electric current intensity will decrease. If I want electric current intensity increase, I will decrease the length, so I will decrease the resistance. Okay, so about the importance. The importance, it's a resistance that you can change its value to adjust the electric current intensity and the potential difference in the different parts of the circuit. What's meant by this? We can change its value by change its length, so we change its resistance. So we can control, we can adjust the electric current intensity and the potential difference. So it's idea, by moving the slider, we can control the length of the wire and that enters the electric circuit. So slider, we can control the length, we can control the resistance, so we can control what? Electric current intensity and potential difference. Excellent. As the length of wire increase, resistance will increase and the current intensity decrease. Excellent. Vice versa, length of wire decrease, resistance decrease and the current intensity increase. Excellent. So the relation between the resistance of conductor and its length, direct relation. Excellent. When we want to represent it graph, we will obtain this straight line passing through conductor. Now we will study Ohm's law. Ohm's studied the relation between the current intensity and the potential difference. He used this electric circuit to study the relation. So if I want you to draw the electric circuit which used in Ohm's law, we will draw this electric circuit. Number 1, battery, positive, negative. Number 2, rheostat with slider. Number 3, ammeter connected in series, and fixed resistance connected with voltmeter in parallel. Okay, this is electric circuit of Ohm's law. Okay, Ohm's change the length of wire, so change the resistance, and took the reading of ammeter and voltmeter. He found that the relation between electric current intensity and the potential difference directly proportional at constant temperature. So the electric current intensity passing through a conductor is directly proportional to the potential difference across it at a constant temperature. There is directly proportional between electric current intensity and the potential difference. Please don't forget, ratio between electric current intensity and the potential difference is constant. It's famous complete. And the graph V, slope V over I, and the ratio between V and I is called R, resistance. The mathematical law R equal V over I, and this magic triangle, I electric current intensity ampere, V potential difference volt, R resistance ohm. So 1 ohm equal 1 volt over ampere. Excellent. From our magic triangle, we can deduce the second definition of the resistance. The second definition is, it is the ratio between potential difference and electric current intensity. What's meant by resistance? It is the ratio between potential difference and electric current intensity. Okay, what's the first definition? Resistance is the opposition that faces electric current intensity. Thank you. Now we want to deduce the definitions of measuring units like ohm, ampere, volt, according to Ohm's law. From magic triangle, ohm, it is the resistance when potential difference 1 volt and electric current intensity 1 ampere. Excellent. Again, ohm is the resistance when potential difference 1 volt and electric current intensity 1 ampere. What about the volt according to Ohm's law? Volt is potential difference when the resistance 1 ohm and electric current intensity 1 ampere. Potential difference when resistance 1 ohm and electric current intensity 1 ampere. What about ampere? According to Ohm's law, ampere, it is electric current intensity when potential difference 1 volt and resistance 1 ohm. Do you understand? From magic triangle, okay? The resistance of conductor, the ratio between the potential difference across the two ends of conductor and the current intensity. The ohm, first word, it is the resistance, and electric current intensity 1 ampere when potential difference 1 volt from magic triangle. The ampere It is the current intensity. First word, ampere, current intensity passing through a conductor when the resistance 1 ohm and the potential difference 1 volt. Volt, first word, potential difference when the resistance is 1 ohm and the electric current intensity 1 ampere. Thank you, and your homework is worksheet 6 and 7, booklet page from 26 to 29. Thank you very much.